Hi everyone. Have you ever deployed a machine learning model that had 98% accuracy offline, only to watch it fail in production because of slow response times or unexpected user behavior? Offline metrics like F1 score or AUC are calculated on clean static test sets. They completely fail to capture real world user behavior, network latency, or system drift. To solve this production to solve this, production teams run A by B testing, deploying competing model variants side by side on live traffic to prove which one performs better. In this video, we are going to walk through an end-to-end ML model A by B testing framework that I built using FastAPI, SQLite, Docker, and Streamlit. It splits like traffic, logs in inference details in the background, and runs statistically significant tests to declare a winner. Let's get into it. Here is how the architecture works. It starts with an asynchronous fast API service. When the server boots up, it loads a two model variant into memory. Model E, our logistic regression baseline, and Model B, our decision tree challenger. Loading them once at startup prevents slowdown input output on active requests. When a client hits the predict endpoint, a traffic router executes a randomized 50-50 coin toss to assign the request to one of the models. Once the model makes the prediction, we calculate the inference latency in milliseconds, but writing this to a database synchronously would create a major bottleneck. To prevent this, we queue a fast API background task to write the log asynchronously. The client gets the prediction response instantly while dealing like the request ID model used prediction value and latency are written to a persistent SQLite database in the background. The entire environment is containerized using Docker Compose to handle volume counts, ensuring a log survive container restarts. Now let's discuss about the math. Welch's t-test. Like consider like a hypothesis null H naught versus the alternative H1 and the significance threshold alpha be like 0.05. If model B is 1 millisecond faster on average than model A, is actually a better model or is just a system background noise. To prove this, we run statistically test using Welch's t-test on the latency distribution using Python's scipy.stats library. The null hypothesis states that both models have identically average latencies. We set our significance threshold or alpha at 0.05. If our test outputs a p-value like smaller than 0.05, we reject the null hypothesis. This gives us statistical proof that one model is statistically faster, removing the guesswork from model rollouts. Let's see this in live action. Here is our dashboard, uh, live Streamlit dashboard. On the left, we can see our current database status and log count. Let's open our terminal and generate